We are going to start talking about some of the most fundamental laws or rules we see around that apply to different things. For example, this is the exponential growth rule or formula. All microbiology, it applies to microbiology, like bacteria grow in this fashion, people grow in this fashion, plants, animals, other stuff we see around the economy. It is also, by the way, the compound interest formula. Anyone who has a mortgage or any kind of debt would know how much it can hurt, right? This is very famous. It's the energy mass equivalence formula or equation. We also have this foundation of quantum mechanics, the Planck equation, that is very, very important in a lot of things we see around us. For example, the light, the heating of our food, many other things. And then we have another one, which is called the second law of thermodynamics. So this funny yet very smart guy once said, "It is the only physical theory of universal content that will never be overthrown." He was so sure about this. But he was not referring to his own equation. He was referring to this guy's equation, Ludwig Boltzmann. At the time he came up with this theory, the theory is summarized as entropy, variation, information, probability. It almost always increases. He came up with this idea and he formulated it as you see on the screen. At the time, it was so controversial. There was such a huge backlash in the scientific community. Some people think it led to his suicide, unfortunately. But his theory remained, and remained it is, we can see it in many things. For example, when you want to paint your house, you fill a bucket with water and you add some paint in it. You buy it from, I don't know, Canadian Tire somewhere. When you drop it in, it suddenly expands and dissolves in the bucket and you have lots of paint to paint your house, right? A train moves based on the same principle. Within its engine, the gas is heated by the whatever is burned there, and then they expand and they push the wheels and it moves. It's not only the train, of course, it's the cars, planes, even electric cars, pretty much anything that moves around us, even things that are, again, animals or non-living things. They are moving based on the same principle. Again, it's around us if you know where to look at. For example, the wind blows and it spreads the seed, or in some cases pollens, and it spreads the life around us. That the life that entrenches itself in many different places, hopefully not only in this world, but other worlds as well. And what's this? What do we have here? It's the Big Bang, right? The Big Bang and what came after that, the galaxies, the stars, the ring objects, nebula, whatever you can think of, or whatever our latest telescopes can capture. It's all around us. It is itself the same basic principle that applies at the macro scale. It even applies to the universe itself. So indeed, at the beginning, there was darkness. It was very boring. There was no point, except there was one very condensed point, which was the singularity. And then, as we've seen in the previous screen, all things started to happen at the same time. All kinds of stars, all kinds of nebula, ring galaxies, other structures, different but similar at the same time. There were more options around everything. Things can evolve in different directions. It has also become much more interesting. There is so much to talk about compared to what was before. Parallelism in the sense that you can see similar planets in this system, similar planets in other systems, but there is also the redundancy in the sense that if you, for example, destroy some of it somewhere. If some part of the world gets destroyed, let's say, but by a hitting object, life can continue in other parts. This is all possible because of the same principle. The universe itself is carrying out on this pillar, foundation. But as T.S. Eliot once immortalized with his The Hollow Man poem, one day it's going to end, and not with a bang, but a whimper this time. Imagine a universe filled with dust particles and nothing much else. No stars, no galaxies, nothing interesting happening. And it's going on and on like that without even now the possibility of evolving to something else. So let's see how it applies to our reality. For example, when we have a server or a computer and we want to do more with it, we can add more memory, more CPU, more storage. But at some point, it doesn't scale up, right? So we have to start producing networks, star topology, ring topology, other topologies. The top box shows different types of networks where computers are connected to each other. The middle one is a different one. It's either a Hadoop or Spark, or latest we can call it a Databricks cluster. So we connect computers in certain way that they can work together. There is parallelism, interesting data crunching going on, and it's a scale out approach. The bottom one is of course a Kubernetes cluster. Similar thing is happening. Instead of one single condensed place, now it's distributed and it's producing a lot more interesting stuff. But where do you think this is going? For example, the largest network we have today is the internet itself. But can we keep adding more computers to the network, expecting more things happening? Or is there a limit? Or is that going to become something less useful at some point? Recently, there was a discussion, IP numbers will be exhausted, and they came up with IP version 6, right? Let's apply it to the data realm. Imagine you start with a table, loading some data on it, and then you want to reuse that data for querying, finding patterns, or other reporting purposes. Imagine you grow your table by adding more data. You end up with thousands of columns and trillions of rows. Is that table really interesting or useful, or is it really not very useful? Of course, we cannot work with that kind of huge single table. We have to create something similar. We have to scale it out. We have to make it more variety, but at the same time connected and producing interesting stuff. So the top here is, of course, a star schema. The middle one is what's called a snowflake schema, which is a connection of tables in a certain pattern so that we can produce analytics. And the bottom one, as you guessed it, is a constellation. It's multiple star systems or star schemas joined together to produce even more interesting insights. But imagine trying to working with something like this. It's a nightmare. Like we cannot keep going like this non-stop. We have to repeat the cycle in different ways. Imagine trying to produce a report from what's on the right and try to join 60 different tables and use columns from them. That's not going to be interesting. We cannot make it really work for ourselves. Similarly, let's say we start with a single machine learning model. We might try to make it more specialized and more generalized at the same time, but it won't work. It can only predict certain things. We cannot expect it to do everything. So what we do, we create ensembles of machine learning models, multiple models doing their piece and then voting for the output result. And the result is determined based on the collective prediction of these models. This works for some cases. Or we can have many different models, each specializing for a specific task. Whenever we need a prediction for that task, we use that model, but the same challenge. If we keep adding more models to the top one ensemble, well, the right model will not be able to, like its voice would be suppressed by all the noise created from so many models. Or at the bottom one, if you create, let's say, 2,000 different machine learning models for 2,000 different cases, well, how do you know which one to use when? It's again a nightmare of a lot of things: energy problems, time problems, effort problems. So Like there are some limits here too. There must be some approaches that can fix it. Now, you can try to do this for everything around you. You can play the same game of applying the entropy rule to identify what's going to happen when this starts, what is it going to evolve into, and what should I expect on the very long term. I want to give you some ideas. For example, ChatGPT, large language models or small language models. Where are they right now and how are they going to evolve? Bitcoin, what's going to happen next for Bitcoin if we are sure it's going to follow the same path we have just seen, dictated by the most fundamental rule of the universe, which is the entropy rule? What's going to happen to data centers? Will they be going bigger and more indefinitely, or will there be something like a consolidation or some kind of energy management? How about quantum computing? How about our own emerging technologies group?